Another example. So F1, 10 newtons, 30 degrees north of east, is somewhere here along the first quadrant. So 30 degrees F1. So therefore, to determine the x and y components of this vector F1, so we can draw a broken line here, and this will be denoted as F1y, or the y component of force F1, and this is the F1x. Or you can extend another line here. That is, if we're going to use this angle. So this is still F1x parallel to x-axis, and this is still F1y parallel to y-axis. Okay, next. How about the force F2, which is 20 newtons, 60 degrees west of north. So therefore, the angle is coming from north and it points west. So 60 is somewhere here. Okay, so this is 60 degrees. And this would be our F2. Okay. Next, let us draw the x and y component. So just draw a broken line here. And of course, this is our F2x parallel to this x-axis. So this is still F2x if we're going to use this angle here. Okay. Next. This is our F2y parallel to this line here, the positive y-axis, F2y. Okay. So this time, sine theta will be used for the y component, then cosine theta will be used for the x component. Okay, so therefore in here, for the x component, x then y component, so we have 10 newtons, positive 10, positive since it is on the first quadrant, both positive. Okay, positive 10 multiplied by cosine 30 degrees. Okay, then for the y component, F1y is parallel to y-axis. So for the y component, still positive 10 newtons times sine 30 degrees. Okay, so this is for our F1. Okay, next. How about for F2? Okay, take a look at class. If we're going to draw this one, okay, if we're going to use 60 degrees, okay, take note that this becomes okay, so this is 60 degrees. Then we have here the F2x, and this becomes the F2y. Okay, so in this case, take note that the x component, F2x, we're going to twist this triangle here. Okay, So this triangle here becomes this way, okay, this type of triangle. Okay, so therefore f2x will now lie along the y-axis. Okay, then the f2y is along the x-axis. So therefore, there should be an interchange of the sine function. So since f2x is now along y-axis, so therefore f2x will take sine function. And f2y, this one, becomes the adjacent side. Okay, again, if we're going to twist this triangle here in this way, okay, so therefore this side here becomes the adjacent side, and this lies on the x-axis. Then the f2x lies along the y-axis. So therefore, f2x multiplied by sine 60. Okay. Then f2y, this one, lies along x-axis. Okay. So therefore, this will take cosine 60 degrees. Okay. But if we're going to use 30 degrees, so therefore this f2y is parallel to y-axis. So therefore f2y will take sine theta. Then f2x is still located along x-axis, so f2x will take cosine. That is if we're going to use this 30 degrees. Number question. Again, if we're going to use 60 degrees west of north, so the f2x here, which is parallel to x-axis, becomes the opposite side and lies along y-axis. So therefore, f2x will take sine function kasi nasa y-axis na siya. Next, f2y, this one, okay, becomes or will be located along x-axis and becomes the adjacent side. So therefore, this will take cosine function since f2y is already along x-axis. But if we're going to use 30 degrees, okay, f2y will take sine 30 degrees, then f2x is located along x-axis, so therefore this will take cosine 30 degrees. Okay? So there is now a change in the uh, angle, the function, if you're going to use the reference angle, which is along y-axis. But if the angle is along x-axis in here, the reference angle is with respect to x-axis, then f or the x component will always take, again, f component will always take cosine function. Then for y component, it will always take sine function. That is if the reference angle is along x-axis. But if the reference angle is with respect to y-axis, so the tendency is the x component will take sine function because it becomes the opposite side or located along y-axis, and the y component will become the adjacent side or located along x-axis, so therefore the y component will take cosine function. Okay, so nabaliktad kasi you are using the reference angle with respect to y axis. So therefore, if we're going to use this 60, so x component of F2 is 20 newtons, 20 newtons multiplied by sine 60. Then the y component, 20. Okay, so this is negative for the second quadrant, negative x, positive y. So negative 20. Then we have 20 newtons multiplied by cosine 60. Okay, so you can now cosine 30 is 0.8666, sine 30 is 0.5, cosine 60 is 0.5, sine 60 is 0.866. Okay, no more question. So this time, find for the resultant of these vectors. So to solve for the resultant, we have summation, therefore we have resultant along x, then we have resultant along y. Okay, so therefore summation of x component is equal to a of 1x plus b okay a 2x plus a 3x plus that. Then summation of the resultant vectors along y, okay, is a1y plus a2y plus a3y plus that. Okay, next, to determine the magnitude of the resultant r. So this is just the same with, so supposing, okay, so we have rx and ry, our x and y component of the resultant vector. Then to solve for the resultant r, this is just the square root of rx squared plus the square root of ry. Okay, next, so this is for the magnitude, the equation for finding the magnitude. Next, for the angle, so we have angle theta. Angle theta is equal to inverse tangent of ry over rx. So how many equations do we have? We have one. Solve first the sum of the x components, then to get the sum of the y components of vectors. Next, you're going to solve for the magnitude. Okay, r is equal to square root of summation of rx plus the square of summation of ry. Then for the direction, so we have theta is equal to inverse tangent of ry over rx. Okay, so these are our equations.